Hi. Let's see the electron distribution in ozone and the canonical forms of ozone. Yes, let me share. Okay. So over here, ozone is O3, all right? We know O3 is ozone. So let's say O double bond O, and over here coordinate bond O. This is what ozone is. Now, when it is double bond, this means oxygen shares this oxygen shares two electrons over here with this oxygen, and this oxygen shares two electrons, right? Which means how many lone pair electrons over here? So this denotes over here there are two lone pair electrons, right? Two lone pair electrons. Okay. Now come to this oxygen. So what happens here? Let's say take this is number one. Okay. Now we are moving to number two. How about this oxygen? Over here, it shares two electron with this oxygen, and over here, coordinate bond. That means both the electrons contributed by this oxygen, second oxygen, right? And let's take this as third oxygen. So when it contributes two electron to this oxygen and two it shared with this oxygen, so which means over here, how many lone pair electrons? Two lone pair electrons. I mean, one pair, two electrons, right? And what about this oxygen, the third one? Is not sharing any electrons, right? So this has all its six electrons over here, three lone pairs, right? Okay. So this is what ozone is. And the canonical form of this, in the sense, the pi electron, movement of pi electrons will be there. The movement of pi electrons you can show just by showing, see here, so the double bond will come over here, the other side, and the coordinate bond over here. And the electron distribution, again, there is a change over here. So this has two lone pairs and this has three lone pairs. Got it? So this is what canonical forms. Shall we see the formal charge also? How to calculate the formal charge? So over here, let's take the oxygen 1. Okay, number 1. So how many electrons are there in the oxygen in the valence shell? So it has 6. So valence shell electron 6. And how many lone pair electrons are there? Two lone pairs, which means 4. So 6 minus 4. Okay, got it? The electrons in valence shell minus the electrons in the non-bonding electrons. And then this minus half of bonded. How many bonded here? This oxygen, number 1 shares 2 electrons, 2 shares 2 electrons. Over here, 4 electrons are there, right? Bonding electrons are 4. So half into, what is it? Half into 4. Got it? So that means 6 minus 4 is what? 2. 2 minus 2, which is 0. So 0 is the charge of oxygen 1. Got it? Let's talk about second oxygen. So second oxygen, how many electrons in valence shell? 6, right? There is no difference in this. But how many non-bonding electrons? 2, right? So write 2. And over here, how many bonded here? And over here it shares 2, this shares 2, so 4 electrons, and 2 it's contributed to other oxygen. So totally 6, above half into 6. Right? So which means what you get? So over here 6 minus 2 is what? 4. 4 minus 3, which is 1. Alright? So which means over here what is it? Plus 1. So what is the charge here? The charge of this oxygen is 0 and this oxygen is plus 1. Let's move on to the third oxygen. So the third oxygen, over here, how many electrons in the valence shell? 6. And how many lone pair electrons are there? 6, right? I mean, lone pairs are 3 and number of non-bonding electrons are 6. 6 minus 6. And minus half, what is it? How many shared? So the number 2 oxygen contributed 2 electrons, right? So a half into 2. So what you get here, children? So you get minus 1, right? So the charge of the third oxygen is minus 1. Hope you understand this. Thank you.